Hello everyone. Welcome back to my YouTube channel. Today topic is important questions based on thermodynamics. If you like my video, please like, share, and subscribe to my YouTube channel. So, let's see some basic questions related to thermodynamics. So the first question is, what is mean by thermodynamics? So, the study of the flow of heat, or any other form of energy, into or out of a system, as it undergoes a physical or chemical transformation, is called thermodynamics. Hence in thermodynamics, we study and evaluate the flow of energy into or out of a system in the form of change in certain properties of the system. These properties include temperature, pressure, volume, and concentration of the system. So, by measuring the changes in these properties from the initial state to the final state, we can get information about changes in energy and related quantities such as heat and work. Now, what are the limitations of thermodynamics? So, limitations of thermodynamics are: thermodynamics is applicable to microscopic systems. A microscopic system means a system consisting of matter in bulk, and not to microscopic systems of individual atoms or molecules. It ignores the internal structure of atoms and molecules. It is concerned only with the initial and the final states of the system. That is, thermodynamics does not bother about the time factor, and it does not tell anything regarding the rate of a physical change or a chemical reaction. Now, what is mean by system, boundary and surroundings? So, a system is that part of the universe that is under thermodynamic study. It may be a reaction vessel, a distillation column, or a heat engine. And the real or imaginary surface separating the system from the surroundings is called the boundary. The part of the universe outside the system and separated from the system by boundaries is called the surroundings. In experimental work, suppose the beaker contained 200 grams of water, which is considered a thermodynamic system, and the beaker and the air in contact is considered as the surroundings. Now, what is the difference between homogeneous and heterogeneous systems? So the difference between homogeneous and heterogeneous systems is: a homogeneous system is made of one phase only, and a heterogeneous system consists of two or more phases. When a system is a uniform throughout, it is called a homogeneous system. And when a system is not uniform throughout, it is called a heterogeneous system. Examples of the homogeneous system are a pure single solid, liquid or gas, mixtures of gases, and true solution of a solid in a liquid. And examples of heterogeneous systems are ice in contact with water, ice in contact with vapor. Here, ice, water, and vapor constitute separate phases. Now, what is mean by phase? So, a phase is defined as a homogeneous, physically distinct, and mechanically separable portion of a system. As we know, a homogeneous system is made of one phase only, and a heterogeneous system consists of two or more phases. Now, what are the types of thermodynamic system? So, there are three types of thermodynamic systems, depending on the nature of the boundary. First is isolated system. So, an isolated system is one that can transfer neither matter nor energy to and from its surrounding. In this system, the boundary is sealed and insulated. Hence, no interaction is possible with the surroundings. Example: boiling water contained in a thermos flask. Since the flask is sealed, no water vapor can escape from it. Also, because the flask is insulated, no heat can be exchanged with the surroundings. The second type of system is closed system. A closed system is one that cannot transfer matter, but can transfer energy in the form of heat, work, and radiation to and from its surroundings. Here the boundary is sealed, but not insulated. Example: specific quantity of hot water contained in a sealed tube. In this system, no water vapor can escape from this system, but it can transfer heat through the walls of the tube to the surroundings. The third type of system is open system. An open system is one that can transfer both energy and matter to and from its surroundings. Here, the boundary is open and uninsulated. Example: hot water contained in a beaker, placed on a laboratory table, is an open system. The water vapor and also heat is transferred to the surroundings. Now, what is adiabatic system? So, the system in which no thermal energy passes into or out of the system is called an adiabatic system. Now, what is mean intensive properties? So, a property that does not depend on the quantity of matter present in the system is known as intensive property. Examples: pressure, temperature, density, and concentration. So, if the overall temperature of a glass of water is 20 degrees Celsius, then any drop of water in that glass has a temperature of 20 degrees Celsius. Now, what is mean for extensive properties? So, a property that does depend on the quantity of matter present in the system is called an extensive property. Some examples of extensive properties are volume, number of moles, enthalpy, entropy, and Gibbs free energy. Let us consider the system of a glass of water. If we double the mass of water, the volume is doubled. And due to this, the number of moles and the internal energy of the system also change. Now, which are the common intensive and extensive properties of a system? The intensive properties are temperature, surface tension, pressure, refractive index, density, viscosity, boiling point, freezing point, and extensive properties of a system are mass, volume, internal energy, enthalpy, entropy. Now, what is meant by a state of a system? So, the condition of the system, defined by its properties, and all that properties are fixed, then it is called a state of the system. Now, what are state variables or state function or thermodynamic parameters? So, the fundamental properties which determine the state of a system are called state variables, or state function, or thermodynamic parameters. The state functions are fixed for a particular state of the system and do not depend on the path by which that state too has arrived. The fundamental state functions of any system are pressure, temperature, volume, mass, and composition. Now, what is meant by path function? So, the properties of the system accompanying a given change in a state vary with the path from the initial to the final state is called path function. Heat and work are path functions because heat and work involved in any change of state cannot be determined solely by the initial and final states. They also depend on how the change is carried out. Now, what is the difference between steady state and equilibrium state? So, the difference between steady state and equilibrium state is steady state. A system which is interacting with surroundings is said to have attained a steady state condition when the properties are at a specified location in the system, do not vary with time. And equilibrium state. A system is said to be in a state of equilibrium if the properties are uniform throughout and they do not vary with time. Now, what are thermodynamic processes? So, when a thermodynamic system changes from one state to another, The operation is called a thermodynamic process. There are various types of thermodynamic processes, like isothermal process, adiabatic process, isobaric process, isochoric process, and cyclic process. Now, what is the isothermal process? So, the process in which the temperature that remains fixed is called the isothermal process. This is often achieved by placing the system in a thermostat that is a constant temperature bath. For an isothermal process, dT equals 0. Now, what is the adiabatic process? So, the process in which no heat can flow into or out of the system is called the adiabatic process. Adiabatic conditions can be approached by carrying the process in an insulated container, such as a thermos. Because high vacuum and highly polished surfaces help to achieve thermal insulation. For an adiabatic process, dQ equals 0. Now, what is the isobaric process? So, the process which takes place at constant pressure is called the isobaric process. For example, the heating of water to its boiling point and its vaporization takes place at the same atmospheric pressure. These changes are said to take place isobarically. For an isobaric process, dP equals 0. Now, what is the isochoric process? So, the process in which the volume remains constant is known as the isochoric process. The heating of a substance in a non-expanding chamber is an example of the isochoric process. For isochoric processes, dV equals 0. Now, what is the cyclic process? So, when a system in a given state goes through a number of different processes and finally returns to its initial state, so this overall process is called a cycle or cyclic process. For a cyclic process, the equals 0 and dH equals 0. Now, what is the difference between reversible and irreversible process? So, the difference between reversible and irreversible process is: a thermodynamic reverse process is one that takes place infinitesimally slowly, and its direction at any point can be reversed by an infinitesimal change in the state of the system. And when a process goes from the initial to the final state in a single step and cannot be carried in the reverse order, it is said to be an irreversible process. Reversible process is imaginary, as it assumes the presence of frictionless and weightless piston. And irreversible process is real and can be performed actually. all changes are reversed when the process is carried out in a reversible direction. And after the reversible process has occurred, all changes do not return to the initial state by themselves. The reversible process is extremely slow, and the irreversible process proceeds at a measurable speed. Work done by a reversible process is greater than the corresponding irreversible process, and work done by an irreversible process is smaller than the corresponding reversible process. Now, what is the sign convention used for heat and work? So, suppose the symbol of heat is Q. Now, if the heat flows from the surroundings into the system to raise the energy of the system, it is taken to be positive. Hence Q is positive. And if heat flows from the system into the surroundings by lowering the energy of the system, it is taken to be negative. Hence Q is negative. Now, suppose the symbol of work is W. So, if work is done on a system by the surroundings, and the energy of the system is thus increased, it is taken to be positive. Hence W is positive. And if work is done by the system on the surroundings, and energy of the system is decreased, it is taken to be negative. Hence W is negative. So that's all about important basic question on thermodynamics. In the next video, we will see another set of questions related to thermodynamics. If you like my video, please like my video. Share this video with your friends and subscribe to my YouTube channel.